Welcome to Kojo's Pre-Algebra, and today we're talking about variables and inequalities. An inequality is when an inequality sign is substituted for the equal sign in an equation. So an equation, instead of having one solution, has multiple solutions. And some of the all the inequalities that you need to know are less than, greater than, less than or equal to, or greater than or equal to. The one thing you want to remember about inequalities is you solve them just like you do an equation. You manipulate the inequality, you manipulate both sides so you can still isolate the variable to find the solutions to the inequality. And then you have to show your work. I went ahead and, instead of going through this, I went ahead and showed you two inequalities, and you should be fairly comfortable with one-step equations. So these are going to be one-step inequalities. And we read this as 23 is greater than or equal to x plus 15. You subtract 15 from both sides, you get 8 is greater than or equal to x. We flip it over because of symmetric property, and we get x is greater than or equal to 8. I want you to notice, though, I drew a number line, because this test says that any number that is equal to 8 or greater than 8 will make this a true inequality, a true statement. And we can use these all kinds of ways in word problems or for businesses. In other words, if you're talking about how much do you have to sell something for to break even on a product, right? So if you have caramel apples, my favorite example, and I've invested, I break down to find out how much money it cost me to do one apple, the cost of apple, the stick, the caramel, my labor. And then I say, okay, that's the cost of the apple. So what's the break-even point for that apple? What would I have to sell the apple for to break even? Well, then you get into this, and that represents the profit. You have to sell it more than a certain amount of money, right? So 15 could be the cost. You can see the cost of the supplies and everything to make the apple and the labor. Then I have to figure out how to arrange my profit around that, right? So inequality is used all the time. Okay, so in this case, x is greater than or equal to 8. And you'll notice I put a number line. This is not in the book yet. We get to it later. But I want to go ahead and introduce it to you because it's easier. You have to represent all the possible solutions for this inequality on a number line. Now it says it's greater than or equal to 8. So you go to the 8 on the number line, and because it says greater than, all numbers which lie to the right of 8 are going to make that a true statement. So we're going to go here, and we're going to circle the 8. But in this situation, we don't know what kind of numbers they're talking about. It could be integers, it could be whole numbers, it could be natural numbers, or it could be all numbers. If it's all numbers, then we have to show that. And if there's no directions, you have to assume it's all real numbers. Real numbers are all the numbers on the number line. So if there's no directions as to what kind of number system you're working with, you always have to assume you're talking about real numbers, which includes fractions and decimals, and square roots and radicals and everything else. So when we come here and it says x is greater than or equal to 8, because it says that it's equal to, we have to have a closed dot on the 8, because 8 will make this a true sentence. 8 plus 15 is 23, and 23 is not less than 23, but it is equal to 23, because that's greater than or equal to. It can't be both. So it's a closed dot, because you're showing that you're being inclusive of the 8. And then you have to show all numbers greater than 8. So you do a solid line because you have to assume it's the real number system. You make a really thick line, and then you draw an arrow at the end. And that is the solution set showing on a number line all the potential answers for x is greater than or equal to 8. Now, if this was separate, we would need to label it right on the number line, x is greater than or equal to 8. If it's immediately below the problem, the inequality that you're writing, you don't need to identify this. But if it's separate, you have to identify it right on the number line so that someone can read what you're saying. More than just going, that says that, but you want to identify it, you want to label all your work. Then you have 12 is greater than k plus 9. We're going to subtract 9 for both sides. We saw it's just like a one-step equation, but now it's a one-step inequality. We get 3 is greater than k. We're going to flip this around. We're going to get k is less than 3. It's the same thing. 3 is greater than k is less than 3. Some students make a mistake and just go k is greater than 3. No. You go up here, 3 plus 9 is 12. It's not equal to it, we have a problem. So that is not true. So the answer can't be equal to 3, right? So if it's not equal to 3, we're going to go to the number line and we're going to circle the 3. The difference is, because it's not equal to 3, the dot has to remain open. Because anything, again, we have to assume we're talking about the real number system. So any number going all the way up to 3 is a solution to this, even if it's 2.99999999999. That's going to make this a true statement. Okay? So because of that, and it's not equal to, it's less than, we have an open dot at that point. Then we draw, because it's less than, we point the arrow this way. We have a solid line on that with an arrow at the end showing the solution set for k is less than 3. So not the 3, because it's an open dot. Everything to the left. So the most important thing that you need to gather from this, besides one-step equations are very similar to one-step inequalities, except the solutions are termed differently, is you have to know how to graph this on a number line, or show the solution on a number line. Open dot if it's greater than or less than. Closed dot if it's greater than or equal to or less than or equal to, because then you have to be inclusive of the number that the variable is being referred to. Okay, I want you to stop the video and try these, and when you're done, come back and we'll check your solutions. Alright, welcome back. How'd you do? Let's see. Now I'm just going to have you check, and I'm not going to go through every step. I'm not going to go through every step. I want you to check. You see how I'm showing my work? You must show your work. You must show your work. Now, I went ahead and labeled the number lines. You do not have to do that if it's directly under the problem. I'm doing that in case if I plop that down on a quiz or a test, just the number line with the solution, and I tell you to tell me what the solution is, then you would label it. That's a good test question. Woo! Just giving you the number line with the solution to the inequality. You don't have to come up with the inequality, you'd have to come up with the solution to the inequality. So check these, and then you'll notice this is less than, so I know I'm going to have an open dot. You immediately go back to the inequality of the inequality equation. This didn't sound good. This is greater than, so I have an open dot, line to the right. This is less than or equal to, so I have a closed dot, line to the left, less than. Greater than or equal to, I have a closed dot, line to the right, because it's greater than. Okay. I want you to, you're done? Well, let me move out of the way. If you want to stop the video and check your work, please do. Okay, let's see what happened. I want you to write down 2 things that you learned and 1 question you still have about inequalities. What? Mr. Al has something to say. What? Cat got your tongue? Oh, no, you got the cat's tongue? Ba-dum-bump. Yeah, kind of corny, huh? Well, let's see what Mr. Al says. Oh! Inequalities have more than one answer. Yeah, they have multiple solutions. Thank you, Mr. Al, for that. Oh, I've got to put his head back on so he can have future thoughts. Have a great night. I'll see you tomorrow. Bye-bye.